Hello everyone, I am here with a new problem. This problem is related to differentiation. Differentiation is very easy portion of mathematics. I don't know how many of you have faced this problem, but this problem is very interesting and it will be fun to find the answer of this question. Let's come to the problem. So the problem is find a function f such that f dash x, that is the derivative of f, is equal to f inverse x. Clear? Okay. But remember, f inverse x is not 1 by fx. Okay. F inverse x is the inverse mapping, of fx. It is not reciprocal of fx. It is inverse mapping of fx. Okay, clear? So we need to find a function f such that its derivative f dash x is equal to f inverse x. Now what will be our strategy? So first we should check a function, or find a function f such that f dash x equal to fx. First we will find a function such that f dash x is equal to fx. Okay, can you find it, a function like this? See, if we take fx equal to some constant c into e to the power x, then f dash x will be c into e to the power x. So f dash x will be fx. In other way, we can also solve it. That is, f dash x equal to fx. That means ddx of fx is equal to fx, or d of fx over fx is equal to dx. If we integrate in both sides, we are taking log c as a constant, or this will become log of fx is equal to x plus log c, or fx will be c into e to the power x. Clear? So if I tell you to find a function such that f dash x is equal to fx, then it is very easy, and we know that fx will be c into e to the power x. Clear? In this case, if we tell you to find f inverse x, what will be the f inverse x? Let fx means y is equal to c into e to the power x. So if fx equal to c into e to the power x, then what will be the inverse of fx? So how can you find the inverse? Let y is equal to c into e to the power x, or it implies e to the power x equal to y by c. Clear? Or if we take log in both sides, ln e base, so it will be log x, it will be x in the left side is equal to log of y by c, or x means f inverse y. If y is equal to fx, then x will be f inverse y. Clear? So f inverse y is equal to log of y by c, and if we take y is equal to x, it will become log of x by c. So the inverse of f, that is f inverse x, will be log of x by c. So f dash x is equal to fx here, but not equal to f inverse x, because f inverse x is equal to log of x by c. So for this problem, we didn't get our answer. Okay. Now look, for getting our answer, we need to find a function f such that f x, f dash x, and f inverse x will be in the same class, or same type. For example, in this case, if fx equal to c into e to the power x, then f dash x will be exponential, but f inverse x will not be exponential, it will be logarithm. So fx, f dash x are similar, but f inverse x are different type of class, belongs to different class. Okay, we have to find f dash and f inverse in the same class. So f will be a function like that fx, f dash x, and f inverse x belong to a same class or same type of functions. Now what will be the functions? See the result. Okay. Let us consider the function fx as c into x to the power n, where c is constant. Now we'll verify whether this function satisfies our required results. Okay. If fx equal to c into x to the power n, then f dash x will be c n into x to the power n minus 1. Clear? Now, what will be the f inverse x? The inverse of fx. Let y equal to fx. The image of x is y. Then y will be c into x to the power n, or x to the power n will be y by c, and x will be y by c whole to the power 1 over n. If we put x equal to f inverse y, as y is equal to fx, so x will be f inverse y, then we'll get f inverse y is equal to y by c whole to the power 1 by n. Clear? If we take the variable y as x, we'll get f inverse x is equal to x by c whole to the power 1 by n. So if f dash x, the derivative of fx, is equal to f inverse x, if this occurred, then f dash x is equal to c into n into x to the power n minus 1, and f inverse x is equal to x by c whole to the power 1 by n. Clear? Now, c n into x to the power n minus 1 is in the left side. So x to the power n minus 1, if we put x to the power n minus 1 in the left side, and cn, if we take cn in the right side, it will become x to the power 1 by n, clear, by c to the power 1 by n into 1 by cn, or x to the power n minus 1 into x to the power minus 1 by n. If we put x to the power 1 by n in the left side, it will become x to the power n minus 1 into x to the power minus 1 by n, and it will be equal to n into 1 by c whole to the power 1 by n plus 1. Okay, this is 1 by c whole to the power n, and here 1 by c is there. So it will be 1 by c whole to the power n plus 1. Now, what will be the power of x? It will be x to the power n minus 1 minus 1 by n is equal to 1 by n into 1 by c whole to the power 1 by n plus 1. So look at the right hand side, it is a constant. N is constant, C is constant, so it is constant. Now the left hand side is a power of x. So if the LHS and RHS are same, then the power of x should be 0, or this relation will hold, this equality will hold if n minus 1 minus 1 by n equal to 0, or n square minus n minus n equal to minus 1 equal to 0. So n will be the root of, okay, x square minus x minus 1, that is plus 1 plus minus root over 1 plus 4 by 2, that is 1 plus minus root over 5 by 2. This is golden ratio. Okay, so this number is a golden ratio. If you don't know about golden ratio, I will take a class on the golden ratio later. Okay. There are two roots. We are denoting one roots 1 plus root 5 by 2 as 5, and another the conjugate roots at 5r. Okay, so the value of n, if we take the value of n 5, so n become 5. Okay, n can also be 5 dashed. So we are taking one value, that is n equal to 5. Now if n equal to 5, then the left hand side will become x to the power 0 and the right hand side will be 1 by n. Okay, from here, from this relation x to the power, we are taking n minus 1 is equal to 0, so it will become x to the power 0, and the right hand side it is 1 by n into 1 by c whole to the power 1 by n plus 1. So we are writing it once again, 1 by c whole to the power 1 by n plus 1. Clear? Now x to the power 0 is equal to 1. Is equal to 1 by n, 1 by c whole to the power a 1 by n plus 1. Now if n is equal to 5, this value will become 1 by n plus 1 will become 1 by 5 plus 1. Now what is phi? Phi is a root of n square minus n minus 1 equal to 0, or n, if we divide by n, we'll get n minus 1 by n minus 1 equal to 0. So phi is a root of this equation. As phi is a root of this equation, it will satisfy phi minus 1 by phi minus 1 equal to 0. And from here, we can get phi equal to 1 by phi plus 1. So we can put phi in the place of 1 by phi plus 1. So we have 1 by c, 1 by n into 1 by c whole to the power phi. Clear? Left hand side is 1. So 1 by, so the value of 1 by c whole to the power phi is equal to n, and c to the power phi will be 1 by n and c will be 1 by n. N means phi. So we are putting phi in the place of n. One by phi, c will be 1 by phi whole to the power 1 by phi. That is 5th root of 1 by phi. So what will be the result? Now see, what is n? N means phi. So we get n equal to phi and c equal to 5th root of 1 by phi. So what will be our fx? Our fx is, we have taken c into x to the power n. So fx becomes, c means 5th root of 1 by phi, x to the power phi. So this is our function, where if we differentiate the function, it will be equal to f inverse x. You can verify also. Okay, if you take fx equal to 5th root of 1 by 5, that is c, into x to the power n, that is 5, then you can check f dash x is equal to f inverse x. Okay. So I am also checking whether this answer is correct or not. So fx is 5th root of 1 by 5 x to the power 5. That is 1 by 5 whole to the power 1 by 5 into x to the power 5. So if fx is equal to this, then f dash x will be, this is our constant, so 1 by 5 whole to the power 1 by 5 into the differentiation of x to the power 5 is 5 into x to the power 5 minus 1. So it is f dash x. Now we have to find f inverse x. Now what will be f inverse x? Let y equal to fx. If y equal to fx, then okay, fx is that is written by y is equal to 1 by 5 whole to the power 1 by 5 x to the power 5. So you have to find the value of x, or x to the power 5 will be 1 by 5 whole to the power, 5 to the power 1 by 5. Okay, we are taking this term here in the left hand side, so it will become x to the power 5 will become 5 to the power 1 by 5 into y, or x will be 5 to the power 1 by 5 to the power 1 by 5, that is 1 by 5 square into y to the power 1 by 5. Clear? Now we know that phi is a root of n square minus n minus 1, that is n minus 1 by n minus 1. So phi minus 1 by 5 minus 1 equal to 0. Now 1 by 5 will be phi minus 1, clear, 1 by 5, or 1 by 5 square will be 1 minus 1 by 5. So x will be 5 to the power, that is 5 to the power 1 by 5 square means 1 minus 1 by 5 into y to the power, okay, 1 by 5, that is x. Now 5 to the power 1 minus 1 by 5 means 5 into 5 to the power minus 1 by 5 into y to the power 1 by 5. So 1 by 5 means from here we can write 1 by 5 means 5 minus 1. So it will be y to the power 5 minus 1. Now 5 into, what does this mean? This means 1 by 5 whole to the power 1 by 5 into y to the power 5 minus 1. Clear? So it is the value of x. Now if we put x equal to f inverse y, so f inverse y will be 5 into 1 by 5 whole to the power 1 by 5 into y to the power 5 minus 1. So f inverse x will be, if we put x in the place of y, it will be 5 into 1 by 5 whole to the power 1 by 5 into x to the power 5 minus 1. So f inverse x is 5 into 1 by 5 whole to the power 1 by 5 into x to the power 5 minus 1. So now check that f dash x and f inverse x are same. Okay, so this is the function where you can say f dash x is equal to f inverse x. Clear? Thank you.